Good morning. We are considering this problem next. Swapping nodes in a linked list. An educative idea keeps unemployment away. And recording an educative idea might get you to the moon. So it's a fairly simple problem, best illustrated with this example. So they give you an input, a k, an integer, a number, and a linked list. And you're supposed to swap out the value from the front of the list and the end of the list, the kth value from the front and end of the list. So in this case, k is 1. The first thing from the front of the list is this first node. We're counting from 1, not 0. Take note. And the first thing from the end of the list is 7, so we just swap those. Now k is 2. We have 1, 2. This is the second one from the front. Then 1, 2. This is the second one from the back, and we swap them. That's all there is to it. For 3, we have 1, 2, 3, and it's the same in this case. So you swap it, but it stays the same. For 5, you go 1, 2, 3, 4, 5, right? And then from the back, 1, 2, 3, 4, 5, and then you swap those values. And we're allowed to change values, so we don't need to reassign pointers or anything. We can just like overwrite the values. I think that explains the problem super well. The solution is really, it's a two-pointer, multiple pointer solution, n pointer solution, similar to the two-pointer pattern that we covered, I think, what, 3 weeks ago or 2 weeks ago. And we're using, again, the in-place reverse over linked list, which is our current pattern under consideration. You can do it in 3 passes, 2 passes, or 1 pass. We're going to do it in 1 pass, even though time complexity asymptotically, right, or time complexity wise, having to run 3 times and having to run once is the same, right? It's still big O of n. It's not like big O of 3n is different from big O of n. It's still linear time, but it's, of course, 1 pass. N is better than 3n. So we will look at the 1 pass solution with this diagram. So we have a pointer at the beginning, at the head of the linked list, and then we're going to move this pointer k times. And then when we hit the kth node, we set assign front to what we see there. And then we start the end and another pointer at the beginning of the list. And this time we move this new pointer and current in tandem till current reaches the end. And it's a trick that lets you automatically know the kth node from the end. Because otherwise, with the other multi-pass solutions, you would have to first find the end of the linked list and keep that number in mind. Basically count the number of elements in the linked list, keep that number in mind, and subtract it from k to know how many times from the beginning you need to go to get to the end. But this way you can do everything in one sweep. You only have to loop through the list once. And I can talk about big O notation right now. That's big O of n and space complexity of O of 1. Because you don't ever need more than these 3 pointers to solve the problem, no matter the length of the linked list, space complexity wise. And no matter what you do, you're only going to loop through the list once with current. So yeah, we can look at the code. Fairly straightforward problem today. So we have swap nodes. This is the function that does the swapping of the nodes. All it does is reassign the data in each node. And so let's go through it. We have count. So the front and end pointers will be used to track the kth node from the start of the list and end of the linked list respectively. So we have our front and end. We initialize them to null, and we have the current, which we start at the head. So while the current is not null, increment the count. If end is not null, it means the kth node from the beginning has been found. Now we can move the end pointer to the linked list to find the kth node from the end of the linked list. Okay. If the count has become equal to k, it means that the current is pointing to the kth node from the start of the list. So you can hold on to this for now. This is the first step, essentially, where we're checking if count is equal to k. If we've gotten to the kth element, we set front to what's in the current node, and we now initialize the end node. That is explained here. So current is moving till it finds k, then we set the front and then initialize the end. That's what this does. Now, current has to keep moving to the end of the list. But now end is no longer null. So the next time we move, end is no longer null. So the way to keep end moving is to check if it's no longer null. It means we found, it's time to start moving end, basically. We found the kth node from the beginning has been found. So now it's time to move the end in tandem with current, because current moves here as well with current.next. So we need to move end.next up until current becomes null. Then this breaks out of the loop. We just do the swap real quick of the values that they point to, and then we return the head and we're done. That's all there is to it. So current is was at the kth value. We assign front, then we start moving end and current together until current is at the end of the list. And it breaks out of the loop. We swap these values and we return the head of the list and profit. And that's all there is to swapping nodes in a linked list. Thank you very much.